All right. Good morning and welcome to Master Talker online class. Today we'll be talking about a probability, and if today is your first day of watching our video, please just click on that subscribe button you are seeing there and then turn the notification bell. You see that bell there, click on it so that anytime we drop a new video, YouTube will notify you. Okay. Now, probability is simply for us to drawing conclusion on what we think will happen for a particular event. Okay. So we'll talk about some definitions of basic terms in probability. Definition of basic terms in probability. Okay. Now the first term we'll talk about is sample space. Sample space. Okay. Now, a set whose elements represent all possible outcomes of an event usually denoted by S. Okay. A sample space is simply a set that contains all possible outcomes of an event. Okay. All possible outcomes of an event. Example, if I have that a single throw, a single throw, okay, of a die. Okay, a single throw of a die. Now the possible outcomes we represent it with S is equal to a set of, if you throw a die, the possible things you can either get 1, or you get 2, or you get 3, or you get 4, or you get 5, or you get 6. Okay, so that is called a sample space. Another example is a single throw of a coin. Okay, now if you throw a coin, the sample space S, as in the possible outcome you are supposed to get, is either you get a head or you get a tail. Okay, so that is that. The launch of a missile. The next one, another example is what? The launch of a missile. The launching of a missile. Now, if you launch a missile, the only thing we need to know is that if you launch it, either it's successful or it will fail. Okay, from a submarine. The launching of a missile from a submarine. So the possible outcome for that S should be is either it is successful or it failed. Okay, so these are the possible outcome for the launching of a missile. So number two that we'll talk about is the event. Okay, don't forget that sample space is simply the possible outcome. That is sample space. Now, an event is now a subset of this sample space. Okay, a subset of sample space. That is how do I put it? Okay, they say example, consider the experiment of tossing 2 coins. Okay, like if you decide to bring some part of this, okay, then you call it an event. A particular, now from the total, just bring out a particular thing you feel will happen, and that is for an event. Okay, so an event will represent it with E. If we have that a sample space, for instance, for this A is 1, 2, 3, 4, 5, and 6. So the event E, the event will be just bring out some part of it, a subset of this, maybe 1, 2, and 4, for instance. Okay, so that is an event. So the next one will now be outcome. Number 3, the outcome. The outcomes. Okay, it refers to all possible distinct results of a trial. Okay, all possible distinct results of a trial. Okay, let's consider the example given so far. For example 1, from this sample space, for example 1, the example of a sample space. Okay, now if you look at this, the possible outcomes is what? How many are they? They are 6. 1, 2, 3, 4, 5, 6. So the outcome for example 1 is what? 6. Okay, for example 2, the outcome is simply what? 2. And for example 3, the outcome is simply what? 2 again. Okay, so the outcome is simply when you throw it, what are you getting? From the word outcome, you're supposed to know. Then the next one is experiment. So please note all these things. But after this, then we'll now solve calculation. Calculation will help you to understand better. Number 4 is experiment. Experiment, okay? They say this is the possible, okay, this is the process through which outcomes are generated. This is the process through which outcomes are generated. The act of throwing a die or tossing a coin, etc. Okay? Example of experiment. Okay, experiment is the process whereby the outcome is gotten. Okay, that process, like throwing a die, the process of throwing a die, that is the experiment you are carrying. When you carry this experiment, now what outcome are you getting? So experiment is the process that is being carried for you to get that particular result that you are looking for. Okay. Experiment can also be called a trial. Let's try this thing and know what will happen at the end of it. Okay, so another word for experiment is what? Is trial. So that is that. Now let's talk about the general formula of probability. The general formula. Now the general formula for probability, they say the probability of an event happening can be given as numerical value x, where x is equal to, they say that the probability of an event, happening, okay, can be given a numerical value x. Okay, so let's see what x will be. So x is equal to the number of required outcome all over the possible outcomes. So the probability is equal to what? The number of required outcome, okay, all over, then the total number of possible outcome, the number of possible outcomes. So that is probability. Now there are things we need to note. Okay, from this formula now there are things you need to note. The first thing you need to note is whenever the probability is equal to 1, if the probability is equal to 1, it means that event is sure or certain to happen. It is sure or certain to occur. So if the probability, you can write it down, if the probability of any event, okay, is 1, if the probability of any event is 1, then that event is certain. It is sure or certain, okay, to occur. So once the probability is 1, then we conclude that this thing must happen. Okay, if we say that the probability of rain falling today is 1, it means that there is nothing that will stop this rain from happening. It must occur. Rain must fall. Okay, so that is that. Now number 2, we say that when the probability is now 0, when probability x is equal to 0, we say that it will never occur. It can never occur. So if the probability of any event is 0, okay, then the event is impossible. Then the event is impossible. Then it is what? That is, it will never occur. That is, it will never occur. Okay, these are small exam questions. Okay, these are little exam questions. Then number 3 is the main one, the range of solution. The range of solution. Okay, the range of solution. So probability ranges from that 0 to 1. Okay, probability ranges from this 0 to 1. Okay, so the range of solution to probability problem, the range of solution to probability problem, okay, is between 0 and 1. Okay, is between that 0 is less than or equal to 1, which is less than or equal to what? 1. So probability will fall between these two things. Okay, so the implication is that we do not have negative answer or greater than 1 in probability. So because of the probability must range from 0 to 1, it means you can never get anything negative and you can never get anything that is greater than 1. Okay, it can be greater than 0, but it must be less than 1. So that is a probability. Then number 4, you need to know, for any event, comma, okay, the probability of success plus failure is equal to 1. The probability of success, okay, plus the probability of failure must be equal to 1. So what do we mean by that? Let me write it. What do we mean by that? We mean that the probability of success plus probability of failure is equal to what? 1. So this thing is very important. It's an important something. So let us say that the probability of anything happening, let's call it x. Okay, probability of anything happening, let's call it x, plus probability of that thing not happening, let's call it x bar, okay, is equal to 1. So whenever you are asked, this formula is very important. So whenever you are asked the probability of something not happening, is simply 1 minus probability of that thing happening. Okay, so very important, you need to note it. Probability of something not happening is equal to 1 minus probability of that thing happening. Okay, so let us continue. Let's solve some calculations to help us understand better what we just explained. Okay, so example said a ball is drawn randomly from a bag containing 8 red, 4 blue, okay, 2 green, 2 green identical ball. Two green identical balls, full stop. Then let's say find the probability that the ball drawn is not red. Okay, find the probability of the ball drawn is not red. Now we cannot get the probability of the ball not drawn to be red. Okay, so what we simply do, we are going to solve it in 2 ways. The first way we can solve it is, first of all, let's get the probability of getting a red. The probability of getting a red is simply red is what? 8 all over the total. 8, 9, 10, 11, 12, 14. So the total is 14 all over the total, which is 14. So if you break it down, you are going to have 4 over 7. Okay, so that is the probability of getting a red. Now, probability of not getting a red, let me call it P of red bar. Okay, P of red bar should be equal to 1 minus P of red. So as simple as that, which is what? 1 minus 4 over 7. So which will give you 7 minus 4 over 7, which is what? 3 over 7. The LCM is 7. 7 divided by 1, 7. 7 times 1, 7. Minus 7 divided by 7, 1. 1 times 4, 4. So that is it. Or we say that probability of not getting a red, in another way, probability of not getting a red is simply probability of getting blue, okay, plus probability of getting what? Green. Yes, now since we did not get red, it's either we got blue or we got what? Green. So an or in probability means to add. So what do we have? Probability of getting blue is what? 4 over the total is 14, okay, plus probability of getting a green is 2 over 14. So if you do that, if you reduce this one, you're going to have 2 over 7 and 1 over 7. So I have 2 over 7 plus 1 over 7, which will give you the LCM is 7. 2 plus 1, which is what? 3 over 7, the same answer. You see? So you can get it in any of the two ways. Now, number 2. Number 2 said the probability that Ade passes a math exam. A math exam is P, and that he passes physics, and that he passes physics exam is Q. Then the answer find the probability that he passes maths and fail physics. And he passes maths and fail physics. Okay, so now whenever you hear or in probability, it means to add. But if you hear and or in probability means and plus, to add. Okay, but and in probability means to times. So you need to note these very important things. So now they said that the probability of him passing mass, so probability of to pass mass, let me call it PM, is equal to P. Then probability of not passing mass should be what? 1 minus P. I hope you know, don't forget. Then probability of passing physics is what? Q. And probability of not passing physics should be what? 1 minus Q. So therefore, probability, then the probability of passing, how do I call it? The probability of what? To pass math and fail physics should be equal to what? Now, probability to pass math is P times probability to fail physics is 1 minus Q. So my answer becomes P in bracket of 1 minus Q. As simple as that. So that is the answer. So if you clear the bracket, you have P minus what? PQ. That's if you want to clear the bracket. So that is that. So the next one we'll talk about is they said if another example, if the probability of x, P of x, denotes the probability that event x will occur will occur and px bar, okay, px prime like this, okay, donates px prime donates the probability that event x will not occur. Okay, which of the following is true? Which of the following is true? Which of the following is true? The first one said that 0 is less than or equal to p of x, which is less than or equal to 1. B said that 0 is less than or equal to p of x. So this one is just less than. So which is less than or equal to 1. C said that p of x plus p of x bar is equal to 1. Okay? Okay, which of the following is not true? Is not true. Okay? Then D said that 0 is less than p prime and less than 1. Okay? Now, if you look at this, you will say that A is not true, B is true. Don't forget that probability ranges from 0 to 1, so there must be equality sign. Then C is true. Okay? They say option D is not true. Option D is not true. This one is not true. Option D is not true. Okay? Look at this. Option A is true. Yes, option A is true because the probability can fall within the range of 0 and 1. Option B is equally true because it can be 0 and it can be 1. But look at this one. The probability of it not happening, should be, the probability of it not happening, okay, should be 1 minus probability of it happening. Okay, 1 minus probability of it happening. So what do we say? Sorry, I don't know where I got this option. The option D says that p of x bar is less than 0. P of x bar is less than 0. Then E now said that 0 is less than p of x bar, which is less than 1. Okay. So this one is not correct because we cannot have probability to be less than 0. And we cannot have probability to be greater than what? To be greater than 1. So D is the one that is not correct. But it can fall within the range of 0 and 1. Okay? So that is that. Now, let's continue. The next one. So the next one said 15 balls. 15 balls in a bag. Made up of red and blue. Red and blue balls. If 6 of the balls are red, full stop. How many red balls must be added? How many red balls must be added to the bag so that the probability of the red ball will, so that the probability of the red ball will be 2 over 3. Okay, solution. Okay, now the probability of the red ball, normally the probability of the red ball should be, they said that the probability of the red ball is what, 2 over 3. Now but the total is 15, so what do I multiply to the denominator to make it 15? So it's 5, so it should be what, 2 times 5 all over what, 3 times 5, so that I'm going to have 10 over what, 15. Okay, so 10 over 15 10 over 15. And is that, sorry, now the probability, they say 15 balls in a bag made up of red and blue balls. If 6 of the balls are red, okay, the 6 of the balls are red, so probability of getting red for the one we have is normally 6 over what, 15. Okay, which is equal to 3 here 2, 3 here 5, which is 2 over 5, and that is the probability of getting 15. Now the probability of, now how many do we add? Let's say, let the number we are going to add be x to get this. Let the number of red balls to be added be x. Okay, now we are adding x to it, so we are going to have this one. Now if we add x to it, so probability of the next one, probability of the next red ball, the new one, let me call it n here, probability of the total one should be equal to what, normally the one we have before, which is 2, which is, let me use the 6 plus the new thing I'm adding, all over the total, which is 15 plus the new thing I'm adding. Because if I'm adding 5 extra, let me say for instance I'm adding extra 5 red balls, I'll add 5 to the 6 and the total will not change, so I'll still add 5 to the 15, and they say that it must be equal to what, that the probability will give you what, 2 over what, 3. So you now cross multiply and get your answer. Okay, as simple as that. So what do we have now? If I cross multiply, I'm having 2 bracket 15 plus x is equal to 3 bracket 6 plus x. So what do we have now? 30 plus 2x is equal to what? 18 plus 3x. So if I collect items, I'm going to have 30 minus 18 is equal to 3x minus 2x. So 30, I'm having 12 is equal to what? X. So which means x is equal to what? 12. So if I add extra 12 red balls, I'm going to have that the probability is what? 2 over 3. We can check it. So let us check it. Check. I'm adding extra 12 red balls to here. So the total ball I'm going to have, the total ball should be what? 15 plus 12, which is equal to what? 27. 27 balls, okay? And then initially I had 6 for the red ball. For the red ball I had was what? 6. Then plus the new one, 12, which will give you 6 plus 12 is 18. Okay? So now we now see that the probability of red ball, the new red ball now, will now be what? Will now be 18 over what? The 37. Is it 27 in total? So if you look at this, you're going to have okay, let me say 3 here, 6, 3 here, 9, 3 here, 2, 3 here, 3. So you see that I'm having 2 over 3 as the new probability. Okay, I'm having 2 over 3 as the new probability. So it's not a difficult something. Okay, the next one we have that they say let P be a probability function. Let P be a probability function on set S, comma, okay, where that set X is equal to A1, comma, A2, comma, A3, comma, and A4. Okay? Then I say find the probability. Okay, they say find probability of A2. Find probability of A2 if the probability of, okay, find probability of A1 if probability of A2 is equal to 1/4, probability of A3 equals 1/5, okay, probability of A4 equals 1/6. Okay, so now we should know normally that the total number of probability should be equal to 1. Please note that the total number of probability should be equal to 1. So which means that probability of A1 plus probability of A2 plus probability of A3 plus probability of what? A4 should give me equal to getting 1. Okay, so you need to know that. So I'm having the probability of A1 that I'm looking for plus 1/4 plus 1/5 plus 1/6 is equal to 1. So what do we have now? I'm having that the probability of A1 plus, if you do the math here, the LCM here is 60, right? I'm having 15 plus 12 plus 10, okay, is equal to 1. So I'm having a probability of A1, okay, plus, if you do here, what you are going to have is 37/60 is equal to 1. So if you collect like terms, you're having that probability of A1 is equal to 1 minus 37/60, which is 60 minus 37/60. So which will give you 23/60. As simple as that. Okay, so the next one, said find the total number of possible outcomes in a throw of three dice. Okay, now if you throw a die, you are going to have 6. Okay, now if you throw a die, now you throw the first one, if you throw the first one, you're going to have 6. Then you throw the second one, you have another 6. Then you throw the third one, you have another 6. So the total solution, the total outcome, should be what? 6 times the next 6 times the next 6. Okay, so which will give you 6 times 6, 36. 36 times 6 is 216. Okay, as simple as that. So the next one said if a perfect die is cast, comma, what is the probability of obtaining a 5? Okay, probability of obtaining a 5. Now if you throw a die, remember that the outcome is either you get 1, 2, 3, 4, 5 and 6. Okay, now how many 5 are you getting here? Just 1 5. So the probability of obtaining a 5 is simply 1 over how many are they? 6 outcome. So that is simply the answer, 1/6. So that is that, 1/6. So the next one said a bag contains 9 identical balls, comma, out of which 3 are blue, comma, 2 are white. Okay, and and the remaining are red. Then I say if a ball is drawn, if a ball is drawn from the bag, okay, comma, what is the probability that it is one, blue, two, not red. Okay, so solution. Now the probability of getting a blue is simply that blue over the total number. So probability of getting a blue is simply the blue. How many are there? There are 3 blue. All over the total number is what? 9. Okay, you are done with that. Then for II, probability of getting a not red means 1 minus probability of getting not red. Let me call it bar like this, is equal to what? 1 minus probability of getting a red, which is what? 1 minus probability of getting, how many red are they? They say that the remaining ones are red. So how many do I have here? 3 plus 2 is 5. 9 minus 5. So we have 4. 4 is now the remaining. So 4 over the total number 9. So my answer becomes 9 minus 4 over what? Over 9. Which is what? 5 over 9. Or we say that since the probability of not obtaining a red, look at another way you can solve that. Probability of not obtaining a red, okay, should be equal to what? Since it's got a red, it must be probability of getting a blue or probability of getting what? A white. As simple as that. Which is what? Since it's not red, it can be blue or white. So probability of getting blue is what? 3 over 9 plus probability of getting a white is what? 2 over 9. So if you do that, you are getting 3 plus 2 over 9, which is taken as what? 5 over 9. The same answer. Okay? The same answer. So the next one said, what is the probability what is the probability of throwing an odd number? What's the probability of with a die, with a fair die, with okay, solution. Now if you throw a fair die, you are going to get 1, 2, 3, 4, 5 and 6. Now the probability of getting odd number is simply, which one is odd number? 1, 3 and 5. So how many are they? 3 all over the total number 6, which is what? 1 over 2. Okay, as simple as that. So the next one, so if today is Tuesday, comma, what is the probability that the next day will be Wednesday? Okay, so if today is Tuesday, what is the probability of that the next day is Wednesday? Automatically we know that after Tuesday the next day should be Wednesday. So the probability of next day to be what? To be Wednesday is sure. Is what? Is sure. And what's the probability of being sure? 1. Don't forget. So the answer is simply 1. Okay. So the last question we're going to solve is this. The last question said the numbers 1, 2, 3, 4 up to 17 are placed in a container. And one number one number is drawn at random. One number is drawn at random. What is the probability? What is the probability that the number is odd? Okay, let me use the word even since we used odd in the other one. What's the probability that is even? Now I have 1, 2, 3, 4, okay, 5, 6, 7, 8, 9, 10, 11. In fact, let me pick all the even numbers from 1 to 17. Even numbers. That is the event. Even numbers. Okay. The even numbers there is what? 2, 4, 6, 8, 10, 12, 14, 16. That is how many are there? 1, 2, 3, 4, 5, 6, 7, 8. So they are the probability of even number. It's simply 1, 2, 3, 4, 5, 6, 7, 8. That is 8 all over. The total number is what? 17. So it's simply 8 over 17. As simple as that. So in our next video, we'll talk about theoretical probability. Please subscribe. God bless you.